Hello everyone. We are going to discuss 11.2, which is arithmetic sequence and series. So please follow along with me. Yeah. So 11.2, arithmetic sequence and series. Okay. So let's share the desktop. All right. Oh, let me see. There is an error here. Hold on. Let me do it again. Let me make sure it's recording. Okay, yes, it's recording. And let me share the desktop one more time. So I'm going to stop it and let's start again. Okay. Now, this is 11.2, which is arithmetic sequence and series. All right. Now, what is an arithmetic sequence? It's a sequence which difference between successive terms are always the same number, so it has a common difference. So an arithmetic sequence is a sequence which difference between successive terms are always the same number. Okay, so it's always the same numbers, and the difference is called common difference. Yeah. So examples of arithmetic sequence. So for example, this is 2, 4, 6, 8, 10, etc. So the first term is 2, A1 is 2, so A1 is the first term, and the common difference, so the difference between each of the successive terms are 2. So 10 minus 8 is 2, 6 minus 4 is 2, etc. So the common difference is 2. All right. Now, the next example is 1, 4, 7, 10, etc. So in this case, the first term is 1. The common difference is, let me see, what is this? 10 minus 7 is 3. 7 minus 4 is 3. So the common difference is 3. Or you could have something like -5, -3, -1, 1, 3, etc. The first term is -5. The common difference is, well, the difference between each of these terms is 2. Yes. So these are examples of arithmetic sequence. Yeah. So what we want to do next is determine if a sequence is an arithmetic sequence or not. So determine if the sequence is arithmetic or not. Yeah. So number 1, an is equal to 2n minus 5. Yeah. So what do we do? So in this case, we will calculate a few terms. Yeah. So what are the terms? So when n is 1, it will be 2 times 1 minus 5. So it's -3. So this is A1. A2, when n is 2, it is 2 times 2, 4 minus 5, which is -1. and then followed by 1, 3, 5, etc. So this is A1 when n is 1, n is 2, n is 3, n is 4, etc. So let's see here, do they have common difference? Yes, so D is equal to 2. So yes, this is an arithmetic sequence. Yeah, so any sequence that has common difference is an arithmetic sequence. Now the second one, what about if I have a different sequence and it is 3n squared? So the easiest way to do it is to write a few terms. Yeah. So when n is 1, this is 3. When n is 2, is 3 times 2 squared, which is 12. When n is 3, it's 3 times 3 squared is 27. When n is 4, it's 3 times 4 squared is 48, etc. So let's see if there is any common difference here. So the difference here is 12 minus 3, which is 9. Here the difference is 15. Here the difference is 48 minus 27 is 21, etc. Yeah. Okay, so basically it doesn't have a common difference, so no, this is not an arithmetic sequence. Alright? Because there's no common difference, yes? Because there is no common difference. Alright? Okay, so let's talk about some formulas for arithmetic sequence. So A is the nth term of arithmetic sequence. Yeah. So an is equal to a1 plus n minus 1 times d. So this is the formula. What is an? An is the nth term. A1 is the first term. And then D is the common difference. Alright. Good. Now, how do we use this formula? Yeah. So for example, so number 1, find the 40th term of the sequence. -7, -2, 3, 8, etc. So first of all, we need to see if this is an arithmetic sequence or not. So let's see what is the difference for each term. So 8 minus 3 is 5 here. 3 minus -2 is also 5. And -2 minus -7 is also 5. So yes, this is an arithmetic sequence. We have A1 is -7. And B is equals to 5. So to find the 40th terms, so we need to find A of 40, A40. So A40 is A1 plus 40 minus 1D. So A40 is A1, -7 plus 39 times 5. So it is equal to, let's see, -7 let me see, what is it? Negative 7 plus 39 times 5, that is equal to 188. Yeah. So the 40th term is 188. Okay. All right. So number 2. Okay. So number 2. Okay. So the 8th term of an arithmetic sequence is 75, and the 20th term is 39. Okay. So find the first term and the common difference. So find the first term. So the first term is A1, and the common difference which is D. Okay? Okay. Now, there are 2 ways to do it. Yeah. So let's see. There are 2 ways to do this. Okay. So we could use this. A 20th is equal to A 8th plus 12D, right? Because you could use this if it is easy for you to think about it. Yeah. So why from the 8th term to the 20th term you keep adding the same differences, and there are 12 of the difference. Yeah. So this is your A8, A9, etc., A10, A11, etc., until A20th. So if you're adding this, you keep adding the D. So plus D, plus D, plus D, and there will be 12 of them. So if this is easy for you to see, then you can just use this. So A20th is A8 plus 12D, and then at that time we will be able to find the common difference D. Right? So there are 12 of them here from A8 to A20th. So let's do it this way, and then we will also do it a different way. Okay? So A20th, we know that A20th is 39, so 39 is equal to A8 is 75 plus 12D. So subtract 75 both sides. So 39 minus 75 is negative 36. So D is equal to negative 3. So the common difference is negative 3. Yeah. So how do I find A1? Then I am going to use this formula right here. AN is equal to A1 plus N minus 1D. So AN is equal to A1 plus N minus 1D, and we have A8 and A20th. So A8 is equal to A1 plus 8 minus 1, that is 7D. Now we're going to substitute the value of A8 and D so we can calculate the value of A1. So A8 is, what is it, 75? Is equal to A1, we don't know what A1 is, plus 7 times negative 3. So 75 is equal to A1 minus 21, right? Now, so we add 21 to both sides, and A1 will be equal to 96. Okay? So this is one way of doing it, is by observing that the 20th term is equal to the 8th terms plus 12 of the differences. Yeah, so the 20th term is 8 terms plus 12 of the differences. Alright? Good. So anyway, what is the other method? So this is method 1. So what is the other method? Now let me copy this part, and then we will copy to the next page so we could continue, yes, with the second method. So edit, where is it, paste, alright. So, sorry, let's see here, and there is an N here. Okay, so basically it's given that A8 is equal to 75 and a 20th is 39, and we need to find A1 and B. So we could just use the formulas and then get to equation. So what is the formula? AN is equal to A1 plus N minus 1B. So I could use it for A8 and A20th. So when N is equal to 8, so A8 is equal to A1 plus 7B. So in this case, A8 here, we know it's 75 is equal to A1 plus 7B. So this is my first equation. Okay, so we use the formula here when N is equal to 8. Now we also can use the formula when N is equal to 20. So A20th is A1 plus 19B, and A20th is 39 is equal to A1 plus 19B. So this is equation 2. Yeah. Now let's see here. We could, I guess, eliminate A1 from equation 1 and 2. So I eliminate A1, the first term. So equation 1, we will multiply by -1. So this is how I usually write it. I hope it's not confusing. It just means equation 1 multiply by -1. So -75 is equal to -A1 minus 7B. And equation 2. So we have 39 is equal to A1 plus 19B. Alright. So what is this? -75 plus 39, that's -36. And then A1 cancels, right? And this is 12B. So D is equal to -3. So this is the same answer as what we got last time. Okay. Now, once we get the D, then we should just substitute into equation 1 or equation 2. And we will get the exact same answer. Substitute D equals -3 to equation 1. So we have 75 is equal to A1 plus 7 times -3. So this is 75 is equal to A1 minus 21. So same as last time, A1 is 96. So which method works? I guess both method works. And which one is better? It is depending on your preference. Yeah. So either one works and either one is good depending on your preference. Okay. All right. So next one, 3. Okay. Let's see, number 3. So we did the second problem using 2 methods. Now let's do number 3. So given, so given, hold on. Okay. So given the recursive formula, okay, so all right. So actually, this is related to the first equation, the previous equation, which is what is given. So so we have that A1 is 96. Actually, this is the previous problem. Yeah, we know A1 is 96 and B is equal to -3, right? So this is from the previous problem. Okay. So should I call it B? Maybe not. Let me call it C. Yeah. Now, so given this, which is actually the previous problem, find the recursive formula. So find the recursive formula for the sequence. Okay, so given A1 is 96 and B is -3, find the recursive formula for the sequence. All right. Okay, so how do we do it? Let's see. So let's list down a few terms, right? So to answer this, let's list a few terms. So 96 followed by 96 minus 3, which is 93, followed by 933 minus 3, which is 90, etc. So actually, I could write down a recursive formula. So A1 is 96, right? And AN is equal to the previous term, AN minus 1, AN minus 1. So the previous term, what do you do to it? You subtract by 3, right? AN minus 1 minus 3. This is true for n greater than 1. So maybe I'll write it here on the second line. So AN is equal to the previous term minus 3, and this is true for n is greater than 1. Okay, so this is a recursive formula. So recursive formula depends on the previous, is a formula in which a sequence is defined in terms of a previous term. So in this case, this is your sequence AN, and the previous term is AN minus 1, and then subtract by 3. Okay. Now number 4, same problem. So given A1 is equal to 96 and B is equal to -3, we want to find the nth term. So this is a little bit different problem. Yeah. So we need to find AN. Well, just substitute the formula. AN is A1 plus n minus 1 B. So AN is A1, this is 96, plus n minus 1 times -3. So equals to 96 minus 3n plus 3. So this is 99 minus 3n. So this is AN. Okay, so 99 minus 3n. All right. Good. Yeah? We're done with this problem. Okay, so let's see. What other problems we should do here before we move on? Let's see. So next problem, number 5. So we want to find each sum. Oh, we haven't talked about the sum. Let's do another one. Okay. So number 5. Find A1 and B also. So let's do one more. Yeah. Given the 12th term is 4. Oh, so we're assuming these are arithmetic sequence. And D of the arithmetic sequence given that the 12th term is 4 and the 18th term is 28. Yeah. All right. So given the 12th term is 4 and the 18th term is 28. So this is almost like problem number 2, and we could do either method 1 or method 2. So we're given, let's write down the given. Given is A12 is 4 and A18 is 28. So let's just use that we have A12, A13, A14, etc. until A18. This is how many difference we have. So plus D plus D. So we know that A18 is A12 plus 6 of the difference. Okay? So A18, which is 28, is equal to A12, which is 4, plus 6D. So subtract by 4 both sides. 24 equals to 6D, and D is equal to 4. Yeah? Now, we will substitute D is equal to 4 to A12. So A12 is equal to A1 plus 11B. Now we will substitute the value. A12 is 4, so we don't know what A1 is, and then 11 times 4. So 4 is A1 plus 44. So subtract by 44 both sides. This is negative 40. So we found that A1 is negative 40 and the B is 4. Okay. Now you could also use the other method. Yes, in which you have 2 equations and 2 variables. All right. Now let's continue. Yeah. So we're done with arithmetic sequence. So the next one is sum of the first n terms of an arithmetic series. So series talks about the sum. Yeah. Okay. So B, sum of the first n terms of an arithmetic series. Okay, so we're talking about Sn. So we're adding. Sn is we're adding all the terms. A1 plus A2 plus A3 plus blah 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 plus An. Yeah. So A1 plus A2 plus A3 blah 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 plus An. Alright. Yeah. Now, there are 2 formulas. So by the way, if I'm talking about S1, S1 is just A1. S2 is the sum of the first 2 terms. So let me rewrite this. So what is S1? S1 is just A1. What is S2? S2 is just the sum of the first 2 terms. And then S3, this is the sum of the first 3 terms, right? Etc. Yeah? So anyway, Sn is n over 2 times a1 plus an. Alright? And the other formula is Sn is n over 2 times 2a1 plus n minus 1 times d. Okay. Alright. Now, why is this formula? Where does the Sn equals to n over 2 times a1 plus an? Where does it come from? So basically, it comes from here. Okay. So suppose you want to add everything through an. So Sn here is a1 plus a2 plus a3 plus blah 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 plus a n minus 2 plus a n minus 1 n minus 1 plus an, right? So I'm going to write it backwards now. So this is an plus an minus 1 plus an minus 2 plus etc. plus this is plus a1 plus a2 plus a3. Okay. All right. So now, when we add these, we have 2 times Sn. Okay. So I'm just explaining why, where does this formula come from? N over 2 times a1 plus an. 2 times Sn. So what is this? a1 plus an, a2 plus an minus 1, etc. But they all should be the same. So you have a2 plus an minus 1, which is the same as an plus a1 here, and then this is an minus 2 plus a3. These are all the same one. So for example, you have 1 plus 3 plus 5 plus 7 plus 9, and this is 9 plus 7 plus 5 plus 3 plus 1. So if you're adding this, you see that this is add up to 10. This is also 10. This is also 10. So they're all adding up to 10, right? So here you can't really see because I'm using a1 and an, but if you add these all up, the top and the bottom, they add up to a1 plus an. Okay, so these are all the same numbers here. Yeah. Now, how many of them? So there are n of them. So n of a1 plus an. So in this case, I have 2Sn is equal to n times a1 plus an. So what is Sn? Well, we divide both sides by 2. So Sn is n over 2 times a1 plus an. Yeah? So that's how we derive this formula for Sn. Okay? Alright. Now, anyway, aside from that, there are some examples. So let me put this below here so I have more space to work on it. So this is just to give you an example that when you add arithmetic sequences side by side like this, the sum will be constant. This is 10. Yeah? Alright. Now, for example, find the sum of the first 100 even integers, even positive integers. Even positive integers. Okay? Find the sum of the first 100 even positive integers. Alright? So now, it's given that, let's write down, the easiest way is to write down all the even integers. So it is 2, 4, 6, 8, 10, etc. And then you have to have the 100th term. Yeah? Alright, so in this case, we don't know what AN is, A100 is, so A of 100 here. We don't know what it is yet. We haven't calculated yet. We can, but we don't have to. So, so what we're doing here, we know that A1 is equal to 2, and the common difference D is equal to 2 also. The difference for each one of these, the D is equal to 2. A1 is the first term, is also equal to 2. Yeah. Now, we have two formulas. Which one do you think will fit? So here I have to calculate AN first, so maybe I'll use this one because I don't have to calculate AN. Yeah. So let's write it down. SN is N over 2 times 2A1 plus N minus 1 times D. So we're talking about S100. The sum of the first 100 term is 100 divided by 2, so it's 50, times 2A1. 2A1 is 2 times 2, plus 99 times 2. Alright, so this is 50 times 4 plus 198. Okay? So 50 times 4 plus 198 is 202. So 50 times 202 is, let me see, 50 times 202, it is 10,100. Right? Okay. So good. All right. Now, number 2. This is sigma notation, which is summation. I goes from 1 through 10 of 4I plus 8. So let's list a few terms, okay? So I goes from 1 to 10. When I is 1, it is 4 plus 8, it is 12. When I is 2, it is 8 plus 8, which is 16. And then 12 plus 8 is 20, and etc. And then the last one, when I is 10, you have 48. Okay? So anyway, I know A1 and I know A10, and we want to find S10. So this is S10. So this is your A1, and this is your A10. Now S10, that's what we want to find, is the sum of all up to 10 here. Now we will use the formula. We know A1 plus AN, so this is 10 over 2 times A1. A1 is 12 plus AN. AN is 48. So this is equal to 5 times 60. So it is 300. Okay? All right. Good. Now, next one, number 3. So we have the sum of the 30th term is equal to 5580. And we know that the 30th term is 360. So how are we going to find A1 and D? Okay, so we have to find the first term and the common difference. Okay, so we could find A1 first by using this formula. So Sn is equal to N over 2 times times A1 plus AN. So I know N, I know AN, and I know Sn. So when N is equal to 31, then we have S of 31 is equal to 31 over 2, A1 plus A of 31. Then we could substitute. S of 31 is 5580 is equal to 31 over 2 times A1 plus 360. Yeah. Now I'm going to multiply both sides by 2 to clear the denominator. So 2 of these and 2 of these. So here I don't multiply these by 2 anymore. Yeah, only one time here. So 2 times 5580 is, what is it? Let me see. 558 times 2 is 11,11160 is equal to, now let's distribute, 31A1 plus 31 times 360 times 360. Oh, so this is 11,160. So, oh, actually they cancel each other. So 31A1 is equal to 0. So what is A1? A1 is equal to 0. Right? Okay. So how do we find D, the common difference? Well, then we will just use the AN, the formula for AN. So we found A1. So AN is equal to A1 plus N minus 1B. So we're talking about N equals 31. So A of 31 is equal to A1 plus 30D. Now let's substitute the value. A of 31, we know it's 360, is equal to 0 plus 30D. So D is equal to 12. Alright, so that's it. We could do one more, which is number 4. Find each sum. So find each sum. Alright. So 1 plus 3 plus 5 plus dot 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 plus 2n minus 1. So let's see, what is this? We know that A1 is 1, okay? And the D, so the difference between each, 1, 3, 5. So we're talking about the sequence, 1, 3, 5, etc. until 2n minus 1. So D is equal to 2, and we know that AN is equal to 2n minus 1. Okay? So Sn, well, we know A1 and AN. So Sn is just n over 2 times A1 plus AN. So, well, we don't know what n is. We don't know how many it is, but we will just leave it as n. So the sum is n over 2. Let me rewrite this. N over 2 times A1. A1 is 1 plus AN is 2n minus 1. So the 1 cancels. So Sn is n over 2 times the 1 cancel here. 1 minus 1 times 2n. So this is equal to n squared. Okay. Now, we also could find these. What about if I have 5 plus 9 plus 13 plus dot 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 plus 49? Yes. Alright. So what do we do in this case? Well, let's write down the terms. The terms is 5, 9, 13, and then etc., and then 49, right? And let's see, so here we know that A1, the first term is 5, the difference is 9. Is that right? Yes, 5 and 9, the difference is 9. I need to know this 49, so is what term? So what is n here? So we will use, we need to find n. So basically here we need to know n. So find n first. Okay? So 49 is what? So, so in this case, to find n, we will do this. 49 is equal to, so sorry, let me see. an is equal to a1 plus n minus 1 times d. So we know that an is 49 is equal to 5 plus n minus 1 times 9. Okay, so this is how we figure out n. 49 is 5 plus 9n minus 9. So 49 is equal to negative 4 plus 9n. So 9n is equal to, what is this, 53? Hold on. Did we do anything wrong here? Give me a minute. So A1 is 5. Oh, I'm sorry. D is not 9. D is 4. So the difference is 4. Yes. Oh, no wonder. Yeah. So this is D. This is 4. Okay. So in this case, the D is 4. Yeah, the difference 4. So 4n minus 4. So 5 minus 4 is 1. So 1 plus 4n. Oh, I'm erasing a lot of stuff. So anyway, 48 is equal to 4n. So n is 12. Right? Now, when I'm adding this, so I need to find S12. So n is 12. So S12 is 12 over 2 times A1 plus A12, which is 49. Yeah, 49, this is A12. So, so if we're adding this, these are 12 terms of these. So 12 divided by 2 is 6 times A1. A1 is 5 and A12. A12 is 49. So this is 6 times 54. So that is just 324. All right. Okay. So I guess we are done with 11.2, which is arithmetic sequence. So we did both arithmetic sequences and series. So series are the summation of all the terms. Not all the terms, some of the terms. Yeah? Okay, so there are 3 formulas, 1 for AN and 2 for SN. Okay guys, I guess we will see you next time in 11.3. Yeah? So write down any questions that you might have and do your homework, and also write down all the questions that you might have and bring it to class. Okay? Alright, so we will see you next time. Okay, so we'll see you next time in section 11.3. Alrighty? Okay, I'm gonna stop the recording and leave the